There are two approaches to this problem, one which is more intuitive and one which is more mathematically rigorous. Intuitively, imagine you start at 12 o'clock. Between 12 and 1, the hands will not overlap. Then, between 1 and 2, they overlap approximately at 1:05. Between 2 and 3 at 2:10. Between 3 and 4 at 3:15, etc. This is 10 times until we get to 11 o'clock. Then, between 11 and 12, they overlap at 12 o'clock exactly, which gives us 11 overlaps in total. Mathematically speaking, the first step would be to calculate what we refer to as the angular velocity of each of the hands on the clock. As you recall, the minute hand travels 360 degrees every hour, which means that every minute it'll travel 6 degrees. The hour hand travels 30 degrees every hour, which leads us to 0.5 degrees per minute. Thus, every minute, the minute hand will travel 5.5 degrees faster than the hour hand. The two hands overlap every time this relative speed travels 360 degrees. Thus, dividing 360 by 5.5, we can find the time between overlaps, which is approximately 65 minutes. Let's leave this as a fraction, as it is a nicer number that we can manipulate. Now, let's calculate the total number of minutes. There are 12 hours in the period and 60 minutes in each hour. Multiplying those two, we get 720 minutes. Finally, to find the time between overlaps, you simply divide the total time by the time between overlaps. So that's 720 divided by 360 over 5.5. And this leaves you with a very neat answer of 11 overlaps in total.